And also, we just started recording the meeting, so we'll go over these. We'll record them and post them on our YouTube channel. So if you wanted to go back and hear something again or see something again, you can go ahead and do that on the YouTube.
Everything you say or do will be used against you in court of law. I'm kidding.
Okay, the first one here is talking about physical and chemical properties. So as a brief definition, physical properties is like changing the state of matter, right? Going from solid, liquid, or gas is a physical change, or density is a physical change, or is a physical property. It's not a chemical property because it doesn't change the substance. So something that changes the substance is going to be considered a chemical property. So like, let me see if it's on there. I was going to give y'all, I'll just say it, but flammability is a chemical property because when you put certain compounds in the presence of heat, in the presence of a flame, it's actually going to cause a combustion reaction, which is going to change the chemical formula of the compound. Thus, it's a chemical property. So something that's flammable is going to undergo a chemical reaction to be something different on the molecular level. Okay. So for A, let me zoom in here. A, solubility. Would y'all say this is a physical property or a chemical property?
Physical.
Yeah, some people saying physical. Sarah is saying physical. Anyone else have any input on this? Yeah, people. Joss, where is that? Cool. We got a lot of people saying physical. Anyone opposed to the idea that it's a physical property? Anyone for a chemical property? Anyone is like, I don't know. How many are anyone? How many of y'all are like, I don't know if this is a physical or a chemical? Looks like most of y'all understand that this is a physical property because when you take salt like sodium chloride and dissolve it in water, you can get back the sodium chloride, right? It just dissolved into its ions, but if you evaporate all the water, you can get your salt back as sodium chloride solid, right? So solubility is a physical property. It's not going to change the identity of the chemical that you're using. So I'm going to put P for solubility. What about density? Feel free to just blurt it out. We're physical, yeah. Okay, some people say physical. Anyone disagree with that? This is a learning environment. So if you feel like, well, I don't really know, I didn't know if it was physical or chemical, say that and we can try to explain that. So everyone here knows that density is physical property. Sounds like, okay. So I guess I don't need to explain why. Okay, what about toxicity?
No, it's chemical.
Someone says two people say chemical. Yeah. So like let's give an example. So like hydrogen peroxide in this form, well, hydrogen peroxide is a very toxic chemical. It can do some interesting reactions that will really harm your body, like radical reactions.
Take Chem 2, you learn about those reactions.
Yeah. So the fact this is right here is a chemical reaction. The formation of a radical. You don't need to know what that is yet. But the fact that you're breaking a chemical bond is going to be a chemical reaction, which is a chemical property. And when you have these radicals in your body, it's very toxic and it can cause a lot of harm to you. So toxicity is something that would be a chemical property. Okay, because you start with one substance, but that substance is undergoing some chemical reactions to cause something toxic in your body. So yeah, it's a chemical property. What about shape? Yeah, this one's a pretty easy one, right? Shape is just a physical property. You can have a piece of gold that looks like a perfect sphere, or you can have a piece of gold that looks like a gold bar, right? But it's, at the end of the day, it's still gold. It doesn't matter about the shape. So it's just a physical property. I already mentioned earlier what flammability is. What's flammability? Chemical, right? Anyone disagree with that? Or was the explanation earlier sufficient enough to justify why flammability is a chemical property? Any questions yet? No?
Well, because it changes the chemical, like,
yeah, so property. So what you're going to learn in a couple of weeks is we're going to learn different types of reactions. Maybe you already did in basic chem if you took it, but like combustion reactions, have you all heard about those yet? So combustion reaction is when you take hydrocarbon or some sort of fuel, in this case, butane is our fuel, and you react it in the presence of oxygen gas. You're going to get two products. You're going to get carbon dioxide. If this is a pure combustion, you'll get two products. So carbon dioxide and water.
And again, y'all go over this in the coming weeks, so don't stress out too much if you don't know it all.
Yeah, if you don't know this, like Rich said, this is, I mean, if you learned it in basic chem, you probably should know it for the foundation exam, but if not, then we'll learn it in a couple of weeks, so don't worry too much. But as we see, there's butane on the left side, C4H10, but on the right side, we don't see any C4H10. Therefore, butane underwent a chemical reaction. It produces a lot of heat in the presence of some flame to produce two different chemicals, right? So we have different chemical formulas. Thus, flammability is a chemical property because it changed the actual chemical that we were dealing with into other chemicals. What about boiling point? Anyone want to explain why it's a physical?
If you boil water.
Still water, right? If you boil water, liquid to vapor, it's still water at the end of the day. It's just changing its state of matter, right? So boiling point is physical, and same thing with melting point, right? So color. I heard you about to say physical, right?
Yeah.
Yeah. Anyone else agree or disagree? Let's see, if you take just clear water, put some red food dye in it, and take another glass of clear water, put some green food dye in it. At the end of the day, it's still water, right? But it's just, you can change the color, you can alter that, but at the end of the day, the chemical formula is still H2O. Okay? So that's why color is a physical property, because you can change the color of something, and it doesn't mean that you're changing the chemical formula. Although don't get that mistaken for if you take a piece of bread and you put it in your toaster and you leave it in there for 24 hours, it's going to be very burnt. It's going to be crunchy. At that point, even though it changed from white to black, that underwent a chemical reaction because now you can't untoast the bread, right? So if a good sign if it's a chemical property is if you can't reverse it, then odds are it's a chemical property. So if you scramble an egg and cook it, you can't uncook the egg, right? It underwent some chemical reactions. So you can't get the egg back into its original state, which was just yolk and that egg white. So physical. All right. Any questions on number one before I pass this off to Rich for the next? No. What about people on Zoom? Any questions? Zoomies? No? Thank you, Sarah. Okay. Rich, you can take over.
All right. Question number 2. List whether the following physical properties are intensive or extensive. So, and justify your answer of it. So give me like a short, brief explanation. So basically, does anybody want to give me a definition first of what an intensive property is?
Isn't it something that depends on, or does not depend on the amount?
Exactly. Intensive, it does not depend on the amount added. So what are some examples y'all can think of some intensive properties? What was that, sorry? Density, yeah, exactly. Because density, if you have like 10 glass beads or like 5 glass beads, the density will be the same. And then you see another one, color. Color is, yeah, also indeed intensive property, because no matter like how much you add, like say you have 10 red M&Ms and like 5 red M&Ms, the color is still red at the end of the day.
For people that might get confused on which one is extensive and intensive, I like to say intensive is independent of the amount of matter present. So it doesn't matter how much is present. That's how I remember it. Maybe that can help you if you're having trouble memorizing.
So right, for the first one, mass, is that an intensive or an extensive property? What do y'all think? So I hear a couple extensives, and it is indeed extensive, because mass, it does depend on the amount added. So say, for example, there's just an empty seesaw with 0 grams of mass on it, and then Dylan and I get on the seesaw, then the amount of mass on that seesaw would increase. So the mass does depend on the amount added, because the mass increased when we got on the seesaw. And I explained this beforehand. Density is indeed an intensive property, because if you have like 10 glass beads or like 5 glass beads, the amount of density is the same. And this will be an important thing later, but the density of water, no matter how much you have, you could have like the entire like amount of water on the earth, or just like 1 droplet of water. The density of water is always 1 gram per kilogram. That's just like a set value that's out there. All right, what about volume? Extensive or intensive? It is indeed extensive, because again, it does depend on the amount added. Like if you have 20 milliliters of water, that's different, right, from 50 milliliters of water. The volume increased. So a way to think about extensive and intensive as well, there's 2 different quantities, or like 2, not quantities, but like 2 different ways you could say something, then it's extensive. Like 20 milliliters of water is different from 50 milliliters of water. That's all I think about it, but that could be. Okay. All right, what about shape?
So intensive.
Some intensive, some extensive. Why do you say intensive?
I don't think it matters how much you have. I don't think it'll change the shape.
That's an interesting one, because like if you have, let's see, if you, I think, I don't know if that's I don't think that you would be asked if shape is an intensive or extensive property, because you could take a sphere ball of some element, let's just say aluminum, and then crush it into a shape as well. It's still the same mass.
So it wouldn't matter, right?
I don't think you would see shape in one of these questions, because I mean, I can look it up really quick, but it might be dependent on the amount of matter present, but you can have a sphere ball that weighs 100 pounds or a sphere ball that weighs 500 pounds. So that's an interesting one.
Yeah, it could be a little bit of both, because like at the same time, right? Like I could be standing here. This is like one shape, but then I could also like do this, and my shape has changed. My overall surface area that I'm taking up has also increased. So there's arguments for both sides, as Dylan said. So like the argument I showed you was the extensive argument, where like shape can be considered an extensive property. The one Dylan said as well also has some weight to it. Like shape can also be considered an intensive property. So y'all probably won't see, like as Dylan mentioned, y'all probably won't see this on your exam, but I'm just gonna put both down. So it's both intensive and extensive. So that makes sense to you?
I looked it up and it says shape is a extensive property. So it says it depends on the amount of matter present. But I mean, to my point, you can take some like a piece of Play-Doh and change the shape of it, but the same mass of Play-Doh. So I mean, it's an interesting one.
And then color, as I explained before, is indeed an intensive property. If you have like 10 red M&Ms, 5 red M&Ms, it doesn't matter. Color's still red at the end of the day. What about boiling point? What do y'all think?
I'd say
So, but intensive side here. Zoom people, what do you think? Intensive or extensive? Right, seeing some intensives.
That makes sense, right? Because if you have a gallon of water versus a cup of water, the boiling point of the water is still 100 degrees Celsius, whether it's in a cup or a gallon, right? So it's independent of the amount of matter present.
Yes, so it is an intensive property because the boiling point of a substance, regardless of like however much you have, is going to be the same regardless of what it is.
Just think if you're like boiling water and you just pour a little bit, it'll still boil at the same rate as like a big pot. So
yeah, I mean, it'll boil at the same temperature, maybe not the same rate, because the one that's smaller boils faster because there's less water to heat up, but the one that's bigger takes longer. You know, I'm sure y'all boil spaghetti. If you put a lot of water in there, it takes a lot of time to heat it up to boiling temperature, right? So yeah.
All right, let's go to the Zoom people again for this one. What about length? What do y'all think? Intensive or extensive? Got a couple extensives. Do y'all agree? Yeah, right. Because length is extensive. It does depend on how much you have. Like, if say for example, I have this pencil. I don't know how much this. I don't know how the measurements of this. Let's say like 5-6 inches, give or take. So this is like a 5-6 inch pencil. But if you like sharpen your pencil down a bit, you can get it down to like 2-3 inches. So in that case, it does depend on the amount added. So there's a difference there in lengths. So in that case, it is extensive. And the melting point, right? Same reasoning as the boiling point. It's intensive. It does not depend on the amount added. Everything boils and melts. Not everything, but like a similar substance boils and melts at the exact same temperature. All right, so that's it for intensive and extensive properties. Do y'all have any more questions? Right. So Dylan will take over now for metric to metric conversions.
How many of y'all are comfortable with metric to metric conversions? That's good. All right. So I feel like if you're not comfortable with it, it's probably one of two things. You forget like milli is 10 to the minus 3, or you get lost because you don't write your units when you do it. So it's one of the two things. Okay. So
honestly, the biggest thing like I've seen like tutoring this concept is like people just haven't memorized their prefixes, so they get kind of like stuck about like which power of 10 to use. So I'd say like biggest piece of advice for these, just memorize your prefixes. Get those like ingrained in your head, like make acronyms if you need to. Just get those memorized. Just get them in your brain somehow.
Yeah, like what you just said. So always start with what you're given. So do you want me to walk you through? Okay, let's do this. I'll walk you through the first one, and then we'll do the B together. So someone will help me talk to me as we walk through it, and then I'll let y'all do that one by yourself, and then we'll give y'all a couple minutes, and then we'll see if y'all get the right answer at the end. Okay. So I'll do one, we'll do one, and then you'll do one. Okay. So I always start with the given number, 754 kilometers. And make sure you write your units. And I just put it over 1. And you can do the train track method like this. I don't do that. I prefer just to do regular multiplication signs, but whatever works for you. And let's see. What I'll do next is I try to cancel out my units. So I know that in 1 kilometer, there is 1,000 meters, okay? So, or you can say 1 times 10 to the third meters. I usually just do 1,000 meters. It's the same thing, okay? So, and we're trying to get from kilometers to meters, so that's it. Our units cancel out, and we're left with meters as our units. So just multiply that out, and you get 754,000 meters. Or scientific notation would say you always have one number and then a decimal point and then the other two. So it'd be 7.54. And then you do 1, 2, 3, 4, 5 times 10 to the 5th. meters. Each of, I'd say either one works. You'll probably just write it in scientific notation just because either one is the correct answer. Okay. Next one, someone help me with this one here. So what's the first thing we should do? Yeah, right, what's given, right? So 86.392. You don't know where to start, at least do this thing. And maybe you can, the train tracks will start to follow. Yeah, meters, milliseconds to seconds. Okay, so someone's saying we should go from milliseconds to second. What some people will do is say there is 1 millisecond is 1 times 10 to the minus 3 seconds. I really don't like that. I feel like that confuses me because it's so weird to think that there's 1 times 10 to the 3 minus 10 to the minus 3 seconds. Like that's just such a small, weird thing to deal with. I'd rather deal with.
Also, there's too many steps. Like you go from milliseconds, 2 seconds, then you have to go back. Like when you could just go from milliseconds to nanoseconds directly.
Well, I was going to do milliseconds to seconds just because that's what Dr. Armand preaches and make less mistakes. But
as you get like memorized with your prefixes, you can go from milliseconds to nanoseconds directly.
Yeah, but what we're going to do is what I would teach everyone to do first if they're first learning this, okay? And then, you, like you said, once you get better at it, maybe you know the direct conversion from milliseconds to nanoseconds. But what I would say is that there's 1,000 milliseconds in 1 second. It just sits right with me a little bit better to think that there's 1,000 milliseconds in 1 second rather than 1 times 10 to the minus 3 seconds in 1 millisecond. Like, I don't know, that just resonates with me a little bit better. Next thing is to cancel out our seconds. So 1 second, there is 1 times 10 to the 9th nanoseconds in 1 second, right? So that's why these two match up. So there's 10 to the 9th nanoseconds in 1 second. You could have also wrote this. You could have said 1 nanosecond is equal to 1 times 10 to the minus 9 seconds. Whichever one works, they're both the same thing. I just prefer to see that there is 1 billion nanoseconds in 1 second, okay? It makes sense to me. Put that in the calculator. And then you should get 86,000 or 86,392,000 euro nanoseconds. A lot of nanoseconds. And if you put that in significant figures, it's equal to 8.6392 times 10 to the 7th. Yeah. Any questions on that one? No question. Okay. So if there's no questions on that, go ahead and try C by yourself. Yeah.
Raise your hand if you all have answers. I with pride. A few more seconds.
Did you press the
Accident.
Does that help y'all see better, or I mean, no, it's okay. All right. What about people on Zoom? How are y'all doing on this? Oh. 33 chats. Okay, let me help you out. Centiliter is 10 to the minus 2, and pico is 10 to the minus 12. All right, well, because there are some people that are done, I don't want them to get bored. So I'm going to go ahead and start, and you can follow along. What's the first thing we should do? At least write down what we have, right? All right. Next, we need to go. So what we should do is go from centiliters to liters to picometers or liters. Okay. So there is 100 centiliters, like someone just said in the chat. You can write it as 1 liter, or 1 centiliter is equal to 10 to the minus 2 liters, or you can say there's 100 centiliters in 1 liter. That makes sense. We also know that 1 liter is equal to 1 times 10 to the 12 picoliters. Putting this into our calculator, we would get 6.92 times 10 to the 10 picoliters. Is that what y'all got if y'all did it? Perfect. Good job, all my Zoomies and in-person people. All right. Y'all feel like you can go do the next one? Yeah. Okay. Let's try to see if we can knock these out quick so that way we can get on to English to metric conversions, because those are the ones that require more memorization of units as well. Always start with your given. So 3.14159 is just a specific number. Grams. We're trying to get to micrograms. So we know that in 1 gram, there's 1 times 10 to the 6 micrograms. Putting that in here, we get 3,141,590 micrograms. Right? Again, it really is just making sure your units are canceled. Any questions on that one? It's awfully quiet here.
Because it's 5 p.m. and y'all are tired.
Okay. Next one. 2.618 kilograms. To go from kilograms to milligrams, we should probably make a visit to our base unit, which is grams. and then go from grams to milligrams. So 2.618 kilograms. We know that in 1 kilogram, there's 1,000 grams. We also know that in 1 gram, for memorization, that there's 1,000 milligrams. Multiplying that in our calculator, you should get 2.618 times 10 to the 6 milligrams. Did I lose anyone yet? Or are we all doing good? This is really just, there's no conceptualizing any chemistry here. This is just straight dimensional analysis.
Great math.
Yeah, exactly.
And good stuff is all it's for.
Perfect, Natalie, thank you. Everyone in here, we're doing okay? Okay. Yeah. These are the weird units. These are the ones that even I forget, to be honest. Decit to the minus 10 or
10 to the minus
10 to the minus 1. Yeah, that's what I forgot. So 10 to the minus 1. Big E, what is that?
decagrams. That's 10 to the first.
Yeah, see, these are the, like,
Again, this is why it's important to create your acronyms so y'all can memorize those prefixes.
what is your acronym?
What is my acronym?
Actually, I don't think I want to. Okay. So start with what we're given, right? 3819. What's that? Decigrams?
Decigrams, yeah.
Decigrams.
DECI, deci.
So decigrams. No one uses decigrams in real life, only on test. And we know that there is 10 decigrams in 1 gram. We also know that there is 10 grams in 1 decagram. So we're essentially just dividing by 100 here, which will get you, what's that, 38.19. Is that right? Yeah. 38.19 decagram. We don't have any. Yeah, so even I, because no one ever uses these units, even I forget what some of these units are, but I just know the main ones like milli, micro, nano, pico, angstrom, kilograms, giga, mega.
You won't deal with the angstroms though until like end of the semester, probably. So.
Yeah. All right. Rich will go ahead and, if there's no questions on that, Rich will go ahead and take over number 4.
All right, number 4. This is your good stuff. I said the math was good stuff, but this is even more good stuff. This is the great stuff right here. English to metric conversions. Why do these exist? America. Because America decided to be different and use all their English units, and then now we got to go flip-flop, convert all our units, and then mess up everybody's time. Anyway, start with a 754,923 millimeters to yards. If y'all look at the top of the worksheet, I did provide y'all with some useful conversion factors that y'all will need to know. For the test, y'all should memorize these most likely because they're not going to be given to you. And yeah, the ones that you're expected to memorize already are like common sense ones, like 3 feet in a yard, like 12 inches in a foot, stuff like that, like those types of stuff. And then yeah, let's start off. So 754,923 millimeters to yards. So I'm gonna walk y'all through this one. So what I would do first, right, is go from millimeters to centimeters, because then I know that from centimeters I can go to an English unit, inches. And then from inches, I can go to feet. And then from feet, I can go to yards. Why I did it this way is because I remember my conversion factor. The conversion factor I used was 1 inch.
Does anyone know what the conversion factor is before you? Okay.
What? Or there's 2 point something, like 2 point what? Yeah, 2.54 centimeters. 1 inch is 2.54 centimeters. I memorized that number. It's very important. So yeah, now let's do our whole pathway. So 754,923 millimeters, right? How many millimeters would you all say is in a centimeter? Yeah, so 10, there's 10 millimeters in 1 centimeter. We're using the same approach as before. I personally like the train tracks. Everybody likes to hate on them, but train tracks are pretty cool. Anyway, what's our conversion factor we set from centimeters to inches? 2.54. So 2.54 centimeters in an inch. And then, right, this is our common sense stuff from here. 12 inches in a foot. And then just to test y'all, how many feet are in a yard? There's 3 feet in a yard. So 3 feet, 1 yard. And if you put all this into a fancy machine called a calculator, there is 825.594 yards. And that is your final answer. So questions about any of that, how I got from the millimeters to the yards, what I did?
What I would have done is gone from millimeters to meters to centimeters. I don't know. That's personally what I would have done. He went straight from millimeters to centimeters because he knew that there's only a difference of a factor of 10. But I would have gone from millimeters to meters to centimeters, then to inches, feet, and yards. It's just how I learned to do it. And I don't like taking shortcuts because I always make mistakes whenever I take shortcuts. But whatever works for you, if you can do that, go ahead and do it. It'll save time.
That's the beauty of these things, right? Like you can do them multiple different ways. So you can you get the same answer, but you can do it like multiple different ways. So I found that pretty cool. I was learning these. So grams to pounds. Anyone want to tell me how I get from grams to pounds? Because I got no clue.
Grams to kilograms to pounds.
Yeah, that's what I would do as well. Go from grams to kilograms to pounds. And then what's it going? So first we start off with grams, right? So 643 grams. And then, right, since we're already on our base unit, there's no need to convert anymore. So there's 1,000 grams in every 1 kilogram. And then what's our conversion from kilograms to pounds? Yeah, so I always mix this up. It's
1 kilogram is
1 kilogram is equal to 2.204 pounds. The way I like to think about it is the pounds are always bigger because you do less weight in kilograms. Like if you go to the gym, like 45 pounds, it'll be a lesser number in kilograms. That's the way I like to think about it. So when you put this into the calculator, you will get a number of approximately 1.42 pounds. Pretty small amount of pounds, but that's what you get. 1.42 pounds. Questions on that one? All right. Y'all can go ahead and try C by yourself. Raise your hand if you all have answers. I with pride.
Raise your hand if you don't know where to start. Be honest. No one's gonna make fun of you here, okay? And if they do, they're pretty rude. And then we can all like jump them after this.
I will personally fight him. Not okay. I can't fight him.
Make sure you cut that one out of the Zoom recording.
Knowing me, I'm not gonna cut anything.
This guy's not on the cut. Anyways.
They typically give y'all conversion versions on a test.
You said, yeah, you have to memorize all of these. I included them on there so like y'all can get like familiar with them. But the idea is y'all should be able to like memorize it. The thing is, they'll give you like, well, there's some more problems like down below in this worksheet. If it's like a unit like you've never heard of before, they'll give you the conversion for that. But if it's like a unit you've worked with like commonly, like inches, centimeters, stuff like that, they'll expect you to memorize those.
Honestly, the best way to memorize it is just do more problems. Like, don't just do flashcards and say, okay, 1 inch is equal to 2.54 centimeters, and then forget about it right when you flip. Just do a bunch of practice problems that require you to constantly recall that conversion factor. You'll get better when you do that.
Memorize inches to centimeters, and anything else they would give it on the test, but I heard otherwise.
I mean, to my knowledge, Dr. Armand is the one that makes all the tests for Gen Chem 1, and he expects you to memorize all the like the common units you've been working with. So what I'd say is like memorize all of them just to be safe. Because there's some more problems in this worksheet, but like I call Dr. Armand type problems, like the ones he would give. Yeah, we probably won't have time for those today, but for sure on next week, on Thursday session, we can go through those. All right, so I'm gonna go ahead and get started now. My Zoom people, what's the pathway y'all use? How'd you all get from centiliters to quarts? What units did you go from? So it started off with centiliters and went right. We got some answers here. We got centiliters to liters to gallons to quarts. Let's call it QZ. Would y'all do y'all agree with this? Centiliters to liters to gallons to quarts. Yeah, that's what I would have done as well. So first route, let's go from centiliters to liters. So 1,538 centiliters, and then as you can see, there are 100. Well, you can't see it, but 100 centiliters in 1 liter. And then anybody want to tell me our fancy conversion factor of what we use when we go from liters to gallons? Yeah, 1 gallon is equal to 3.79. And what are the units? Sorry, not units. What is the conversion factor from gallons to quarts? Yeah, 1 gallon is 4 quarts. Again, you're expected to, I think it's QT actually, but who cares? I'm just going to write it out 4 quarts. All right, so solve it out. And if you plug this into the calculator, you get 16.23 quarts. So questions about that? Like on how I got from one unit to the other? Because honestly, with these problems, it's just finding a link. Like what I do is like, I establish my link first, like how I'm going to get from each unit to each unit. And then I just plug in my conversion factors and go from there to do the math. My Zoom people, y'all doing good? Y'all understand?
Put a yes in the chat, everyone.
Or an F in the chat if you don't know.
Yeah. That's crazy. There we go.
Seeing no F's and multiple yeses. All right, let's go through this last one right here. This is probably all we have time for. So 85.64 gallons to milliliters. Anybody want to walk me through that one? What's y'all's thought process in this?
Gallons to liters per milliliters.
That's what I would do as well, yeah. So let's use a different color. Why not? So can't see that. Let's do right here, gallons to liters to milliliters. And right, so again, we do our 85.64 gallons. And how many liters are in a gallon? Yeah, so 1 gallon is 3.75, 3.79 liters. And then from there, right, how many liters are in milliliters? 1,000 exactly. So 1 liter has 1,000 liters. And if you plug this in to a fancy device called a calculator, you will get 3.246 times 10 to the 5 milliliters. Or if you want to be extra and write it out, it is 1 second, 3.246, 1, 2, 3, 4, 5. It is 324,600. Both of these mean the exact same thing. All right, so do y'all have any further questions? All right, Zoom peeps, how we doing? Y for you got it, F for you don't got it. All right, nobody's asking why, so we're going to move on to some dimensional analysis problems. We'll probably have time for one, if even that.
Okay, we'll do this one a little quick, and then before I let y'all go, I just wanted to.
Or maybe we should do part B, because that's a quick one.
Okay. Yeah, we'll do part B. So Rish ran the bag at a velocity of 6.46 miles per hour. Okay, so let's write that first. Miles per hour. How fast did Rish run the bag in meters per second? Good question. So the only conversion I know from English to, in terms of length, from English to, I'm sorry, I can't think, English to metric is inches to centimeters. So maybe you can learn some other conversions that can get you directly from miles to meters or feet to meters or something. But if you don't know any of these others, then you need to get from inches to centimeters, which is a lot of conversions. So what I would do is, we know that in 1 mile, this is stuff that we should know, is 1 mile is 5,280 feet. We know 1 foot is 12 inches. And then we know 1 inch, and this is where we go from English to metric. So we use our conversion of 1 inch is equal to 2.54 centimeters. So 1 inch is equal to 2.54 centimeters. And now we go from, you know that there's 100 centimeters in 1 meter. But that's not, we're not done because we're still in hours, right? So we know that 1 hour is 60 minutes. So let me cross out everything we already canceled out. So miles were gone, feet were gone, inches were gone, centimeters were gone. We're left with our desired unit on top, meters. And now we're trying to get to seconds. So
what Dylan's doing right now is a great way to like check if you're doing the problem correctly. Like you want to make sure all of the units that you don't need cancel out, and you're left with the ones that you asked for in the problem.
So now 1 minute is 60 seconds. Let's make sure all the units cancel out. So 1 hour, hours cancel out, minutes cancel out, and we're left with our desired units. Plugging this into a nice calculator will get you, Rish ran the bag at 2.89 meters per second.
Pretty quick if you ask me.
Yeah. Okay, that's all we have for today, but I'm gonna try. I just want to say something before y'all go, and it didn't seem to help last semester, but after every exam, so Rich and I would keep stats on every person that goes to all of our tutoring sessions or our recitation sessions every day that we had them leading up to the exam. The students that attended all those sessions would consistently score 15 to 20 points higher than the class average. The students that would come only the day of or the week of the exam didn't see a change in their class, like their grade to the class average grade. So if you're really wanting to get the most out of these sessions, you should be coming to as many as you can. I know some of y'all might have class time conflicts, but you can still do these worksheets and then look at the recording afterwards.
And also, like, if you have any questions about them, like, feel free to email us. Always
Or
check our email.
Yeah, group me or whatever. But like I was saying, the people that actually reap the results from coming to these sessions are the people that go every single week, not just the week before the week of the exam, okay? So that may incentivize y'all to want to come to these more often rather than just the week of the exam. It's in your power to, you know, make it out here and come do this, but I can't force y'all to come. But it's something that we did see a correlation between the students that came every single day versus the students that only came on test days or the week of the exams. 20 points different on an exam is more than a little over 2-letter grades. But yeah, that's all I have to say. So I hope that we see more of y'all or see y'all not only this week, but the week after. And yeah, so can you send the YouTube link? Sarah, are you in the group meeting? Hold on. Let me stop sharing my screen really quick and I can just try to pull up the group name.
Yeah. Do you recommend that we go from miles to B, or do you recommend miles to kilometers? Or does it matter?
It doesn't really matter. I included the miles to kilometers one on there because y'all might have to memorize it.
Okay. Do you know which one you or they usually work with? It's gonna give me.
All right, I'm sharing the QR code right now on my screen. So y'all can go ahead and use that.
Here's the way, like, if you don't want to like memorize stuff.
Yeah.
So
Same thing.
What professors do y'all have? How many of y'all are from like Dr. Armand's class? Sadegi. Nice.
what? Good? Y'all think it's good?
Wait, who'd you say?
Oh.
Yeah.
Yeah. All right, well, if there's no questions, y'all are free. I mean, y'all have been free to go this whole time.
It seems a little like,
Yeah.
a little scary, but he's like, he's a good